Please go to elithecomputerguy.com and failednormal.com to see the videos that are too dangerous for YouTube. Welcome back. So in this video, we're going to take an Arduino Uno Wi-Fi board and an analog temperature sensor, and we are going to create a visual alert temperature system. Basically, what we want to do is we want to be able to see what the temperature is in a certain environment, and then we want to be alerted if there's a problem. So what's going to happen is we are going to be able to go to the IP address of the Arduino Uno Wi-Fi board. When we go there using a web browser, we are going to simply see a very large number, and that's going to be the temperature that the analog sensor is currently reading. So we're going to make that in a very large font. Now, if the temperature is under 76 degrees, we are going to make that number green. So this is the number, it's green, so it's good. If it's above 76 degrees, but below 82 degrees, we're going to see that very large number, and it's going to be yellow. So it's going to show us the number, it's going to show us the yellow to say, hey, there might be a problem. Maybe not, maybe you know what's going on, but you might want to take a look into it. And if it's above 82 degrees, we're going to see that large number, and it's going to be in red. Now, one of the things that we have to do with this system is when we go to a normal web page, that web page only refreshes when we tell it to refresh. So that's a problem that you can get into when you're using a web page in order to look at readings coming in from a sensor, is it only refreshes when you tell it to refresh. So, you know, you first turn it on, you first open that page, and the number is good, and then you walk away and you think all day that the number is good because you've never refreshed the page. And so you don't want to have to manually go over and refresh the page. And so one of the things that we're also going to do with this particular project is we are going to add metadata that forces the page to automatically refresh itself every 5 seconds. So every 5 seconds, it will refresh the web page that's being presented by the Arduino Uno Wi-Fi board. And so as the temperature goes up and as the temperature goes down, that page will dynamically refresh so that we're always looking at relatively recent data. And you know, our server room isn't overheating, but we're sitting there looking at a screen that was literally created 5 hours ago. So with this project, we're going to be using the Arduino Uno board, a simple analog temperature sensor. Gonna throw this on a breadboard and show you how this works. So with that, let's go over to the workbench. I can show you how to build the physical components of this project. Then I'll show you the code, and I'll show you how all this comes together. So these are the only components we need for this particular project. We've got a breadboard, we've got our Arduino Uno with Wi-Fi, and we've got an analog temperature sensor. We shove the analog temperature sensor into the breadboard, we plug in the ground, we plug in the VCC, the power, the 5-volt power, and we plug in the sensor. And so those are the only connections we're going to need to be able to make this project work. From there, we bring this over, we plug the power, the VCC, into the 5-volt, we plug the ground into one of the ground connections on the Arduino board, and we plug the sensor. We're going to be using A0. Again, this is an analog sensor, so we're going to use one of the analog connections, and we plug that into A0. And with that, that is literally, other than plugging this thing in, that is all you need to do. Again, I will remind you, when you're using something like the Wi-Fi board, and especially when you're going to be accessing it through an IP address or such, you do not have to have this connected to the computer once everything is set up. Again, you can plug in a little USB power supply like this. You can plug in a power adapter, whatever. This can be 100% separated from a computer and continue doing whatever it is you've told it to do. So with that, let's go over to the computer and I can show you the code to how to build this thing. So here's the sketch for this particular project. Now, it's going to start to seem a little bit more complicated than other sketches that we've done in the past, but if you just break it down to its core components, you will realize that it's rather simple. One of the big things with this particular sketch is that we're going to be coding for the Arduino, plus we're going to be using HTML, and we're going to be using CSS. So this is one thing where a lot of people ask me, Eli, what's the best programming language I should learn? What programming language should I learn as as if it's an individual thing. And what you find in the real world is many times you're going to be using multiple languages, even to do something relatively simple. Literally, all we're going to be doing is showing, the number for the temperature reading and changing the color and size of it. And to do that, we're going to be coding for Arduino, and we're going to be using HTML, and we're going to be doing CSS, even for a project as simple as this. So anyways, let's go up and start taking a look at this. So the first thing we need to do is we need to include the libraries that are required for the Wi-Fi connection. So this is for the Wi-Fi and the communications protocols. So we're going to include spi.h library and Wi-Fi9.h library. This simply gives us what we need to be able to connect to a Wi-Fi network and be able to communicate. Then the next thing we're going to do, since this is a temperature project, is we need to define the sensor pin. So what analog pin is the analog temperature sensor on? And so we're going to call this sensor pin, define sensor pin, and we're going to set that to A0. From there, we're going to go down and we're going to set up the Wi-Fi information. So char SSID, so basically what is the SSID? I've set up a guest network on my system called test, so the SSID is test. Then char pass, this is for the password. I've set this to blank because my network, I've set it to blank, so I don't have to do any troubleshooting while I'm doing these videos. If you have a password, plug that in there. Then we have int key index, so if you're using different keys on your Wi-Fi network and you need to give the index number, this is where you would do it. We don't have that, so it is simply set to 0. The next thing we have to do is we have to create a variable for the status for the wireless connection. So we create int status equals WL underscore idle underscore status. So this simply creates that variable and then sets the value to basically idle. We'll use that for the connection. And then Wi-Fi server, and then we're going to set the server to port 80. So this is the HTTP port that we'll be using. So we're just going to plug in 80. You can modify that port number here if you want to. The next thing we're going to do is we're going to create two variables for the if-else, else statement that we're going to be dealing with as far as the temperature is concerned. So basically when we're dealing with this, there's two numbers that we care about. What is the high temperature? What is the, oh no, this is way too hot temperature? And that's the variable high temp, and we're going to set that to 82 degrees. And then what's the good temperature? What's the temperature? As long as it's under that, we're happy. And so I've just simply set that to 76. So I've created these variables and I've set these variables here to make life easier if we need to modify it. So we can, if I need to modify these numbers in the future, I can simply come back to this one place and modify the number versus having to go through here and change it multiple times. Remember, the more times you have to modify something, the more likely it is you will mess it up. So I can just simply write the code down here. I can just simply say temperature F is greater or equal to high temp. And so that's the value of that variable. Now, instead of having to go through and modify the number 5 or 6 times, I can simply modify that one place up here with these two variables. Then what we're going to do is we're going to come down here and we are going to set up the environment. So the first thing that we're going to do is serial.begin 9600. So we're starting the serial monitor. The next thing that we're going to do is we're actually going to start the Wi-Fi connection. So while status does not equal WL connected, serial, it's going to print out to the serial monitor attempting to connect to network named, and then it's going to give the name test. Then the status equals, and we're using the function Wi-Fi.begin SSID and pass. So it's going to feed the SSID and the password to this function, and it's going to try to connect to the Wi-Fi network. It's then going to delay for 10,000 milliseconds or 10 seconds. So while it's not connected, it's just looping through this. When it finally connects, then it'll server begin. So it'll actually begin the server service. Then it'll serial.print SSID, what the SSID is, and then this is how you get the IP address and print it out. So it'll print out the SSID and it will print out the IP address. Again, this is the kind of thing you need on these types of projects because you need to know what the hell the IP address is. You can code all this perfectly, but if you don't know where the IP address is, then it's going to be impossible to access. And that's now the environment that's set up. Now we're going to go into the loop. The first part of the loop, this is how we are able to obtain the temperatures. So we've done analog temperature sensors 1,000 times at this point. I'm not going to go into this, but basically the important thing to understand here is this is how we get the value for either temperature C, temperature Celsius, or this is how we get the value for temperature F, temperature Fahrenheit, and that is what we're going to be testing against in the if else statement. Then we're going to come down, and we've got all this code right here, again, that has to get written out. And basically, this is for the communication between the web browser and the Arduino. Again, we're coding this out, so we actually have to tell the Arduino how the communication happens. You know, who contacts who first, who gets to talk, so on and so forth. And so this simply says Wi-Fi client equals server available, so the server is available. If there's a client, it's going to serial monitor print. It's going to print out on serial monitor new client, and then it's going to do while client is connected, if client is available. Basically what this means is it's going to print out the client information. So when your web browser connects to the Arduino, it's going to print out that information on the serial monitor. And then when it gets to a new line, so if C equals new line, and basically if current line.length equals 0, then we start actually sending stuff to the client, to the web browser. And this is where we get to the meat and potatoes of the real project that we're doing today. So the first thing that we have to do here, before we get to the if else statement, is we're going to actually print out some metadata. And what this is for is to have the web page auto refresh itself. Again, one of the things you have to be thinking about when you display information is how often is that information going to be to be refreshed. So if it only gets refreshed every hour, that means literally it might be what you're seeing may be 59 minutes old when you're seeing it. And so again, especially for something like a temperature sensor or a temperature alert system, you have to think about how often you're going to refresh. And do you want to manually refresh, or do you want to have it be automatically refreshed? For this, since all we're doing is literally we are simply printing out a number in a pretty color, then I want this to auto refresh on its own. Having the page itself auto refresh is a useful thing. And so what we're going to be doing here is we do client.println head meta http-equiv equals refresh. So this is saying refresh content every 5 seconds. So basically doing this, it refreshes the content every 5 seconds. Now you'll see these backslashes here. So basically if you're writing this in CSS, this right here is what it will look like. But the problem is when you're writing this code, you have to be able to tell the Arduino what code should the Arduino care about and what code is a web browser going to care about, right? So since we print everything between the double quotation marks, if we don't escape out, that's what a backslash is. If we don't escape out, essentially what's going to happen is the Arduino is simply going to send this, right? Send everything between the double quotation marks. Sir, yes, sir. And so it's literally going to do what you told it to do, which is that. That's not useful. So what you want to do is you put in the backslash, and it escapes out characters that you don't want the Arduino to interpret. So basically what happens is the Arduino will get to that backslash and will know the next character, it's not for me, it's for something else. And so what will happen is then what will be printed out is the backslashes will be ripped out, and you'll just get a nice solid piece of CSS or HTML or whatever here. So that's a big thing with the backslashes. Anytime you get to a problem, like if you're writing something and you start to see black like this, you know you're running into an issue where the Arduino thinks that it's finished interpreting what it's supposed to interpret, and so you put a backslash in there and make sure everything is in blue that's supposed to be in blue. So what this is going to do here is going to say for the entire web page, refresh every 5 seconds. Then we're going to come down here to the if else statements. So what we're going to say is if temperature in Fahrenheit, is greater or equal to high temp. The value of high temp is 82. So if it is greater than 82, we're going to do client.println. And then what we're saying here is we're doing the tag for H1. So we're putting a little tag, we're putting a little CSS here. We're saying H1 style equals color red. So we're going to make it color red, font size 400 pixels. So we're going to make it big. You're going to notice we've got these backslashes in here, and those are to escape out of those double quotation marks. If you don't escape out of the double quotation marks, you will run into problems. So this starts the H1 tag, then we're going to do client.print, and we're going to simply do the value of temperature F, whatever that is. Then we're going to do client.println and close the H1 tag. So what this is going to do is this will print out whatever temperature it is in Fahrenheit in big and red. Then else if. Else if temperature Fahrenheit, temperature F, is less than high temp, less than 82, and temperature F is greater or equal to good temp, so if we go up here, good temp is 76, then what we're going to do is basically the same thing. The difference being we're going to print it in yellow. So this is going to print it out in yellow, again, at that 400 pixels. Then if we go down, else, so if it's not above 82, if it's not between 76 to 82, then it should be good. And so we're just simply doing the else, the exact same thing we did up here. The difference being is the color is going to be green now. Then as far as the Wi-Fi thing is concerned, we're then going to have the break, and then we're going to have basically all of this here, which again is basically copy and paste. And this is what's required in order to have the Arduino to understand how the Wi-Fi communication is supposed to happen. And then with that, all we have to do is we simply have to upload the code. So we're going to upload the code there. So it's uploading. And then once it's finished uploading, we're going to go to the serial monitor. So we go to serial monitor. And so now it's attempting to connect to network named test. So it's now currently trying to connect to that SSID, and this will take a few seconds. Again, 10 seconds in the real world. In the real world, 10 seconds is no big deal. 10 seconds while you're trying to teach a class seems like forever. But there we go, we got it connected. So it's now connected, SSID, it's connected to the test Wi-Fi network, and this is its IP address. So we can copy that if we want. We can go over to Google Chrome, open up Google Chrome, do a Control V, hit enter, and there we go. So look at that, look at that. So we now see that the temperature sensor says 73.84 degrees. 73.84 degrees is of course lower than 76, so it's good. Now look at that, it auto refreshed after about 5 seconds, and so we now see it's 72.96 degrees. Now what I'm going to do is I'm going to put my finger on the temperature sensor like I normally do for these projects, and then in a couple seconds it's going to auto refresh, and when it does, look at that, it's now 83 degrees. Oh no, it's too hot, it's too hot. So now I'm going to take my finger off. Even after I took my finger off, it's now up to 86 degrees, but you can see how it's automatically refreshing. Now we get to 81 degrees, 0.75, so that's a little bit below 82 degrees, so that's now yellow, comes down to 78.23 degrees, and then now it should keep coming down since my finger is off. So what we can see here is that we've created a very large number. So again, this is something that you could use in a very standard web browser. Imagine you have a Raspberry Pi laying around or something like that, and you want to be able to have some kind of display for different temperatures for different places. So again, something like a server room. So this shows you how you can have this Arduino Uno Wi-Fi sitting in a server room. It's connected to your Wi-Fi network, and then you can have a display like this up anywhere that's connected to the network that can connect to it to the IP address, and it will simply refresh and show you what the temperature is, and it will alert you if the temperature gets too warm. Again, like you're just sitting here at 72.96 degrees, it auto refreshes. Oh no, it's 83 degrees. Get to the server room now, now. So that was another little project using our Arduino Uno Wi-Fi, and of course our trusty little analog temperature sensor. I like using the analog temperature sensor because it gives you the ability to change the values rather dynamically and have your code with those if else statements, be able to trigger different events to happen. But again, with this kind of thing, remember, you can have the same type of stuff with motion sensors or with distance sensors or some other type of sensors. Basically, all we're doing is we're taking that sensor input, and then we're saying, depending on what that sensor input is, do these things. Before we've turned LED lights on, we've written to LCD screens, we've turned motors on, again we've turned like fans on, and now all we're doing is we're printing out to a web page, basically to a web browser. And this is what I really want you to be thinking about with Arduino projects and with IoT, because back in the day, back 10 years ago, when we talked about input and output as far as computers were concerned, we were talking about the mouse and keyboard as far as input was, and output was either the screen or the printer. Input, mouse, keyboard, output, screen, printer. What I really want you to be thinking about now with these IoT projects is your input could be 1,000 different types of sensors, and your output could be a lot of different things. Again, do you just need a little red LED light going off? Do you want a buzzer going off? Do you want a big old display with a number that tells you something specific? This is one of those things you have to think about the IoT world. It's not just simply text on a screen or a picture or something like that. You really have to be thinking about okay, there is a problem. The sensor has detected something that's either good or bad. Now what do you want to have happen? Again, print out to an LCD screen. Do you want a buzzer? Do you want something on a web page? Do you want something to be documented into a database or printed to a file? All of these things are possibilities with outputs, and all of these are very relevant in this IoT world. So that's why I think this kind of stuff is nifty neat. And again, don't get too hyper-focused when I show you an analog sensor or something. A lot of people get hyper-focused on, and I'm trying to show you the overall concept. You take this, you copy and paste and figure out what you want to do. One of the other important things to be thinking about with this small little project, though, is in this project we're essentially using 3 languages. I know you don't really think about HTML and CSS as languages, but work with me here. And this is an important thing you have to understand about this new world of technology, is you're dealing with hardware, you're dealing with sensors, you have to be thinking about output. And again, when we talk about languages, so many people, when they think about programming languages, they say, what language should I learn? What language? And what I want to show you here with even this exceptionally simple project, we're using Arduino, which is a derivative of C, C++. We're using CSS, and we're using HTML. Even in this, again, this is still less than 50 lines of code. And so that's one of the things you have to be thinking about once you start building out these projects, is it's not about one language. It's like when we start making more complicated things, where we'll add JavaScript, we're going to add PHP. Within a short amount of time, we may literally be using 5 or more languages for, again, something that is a relatively simple project. So that's the other thing that I really want you to be thinking about, is you're not going to be learning one programming language. You're not going to be learning one technology. It's about learning all of this stuff and then figuring out how it goes together. So as always, I enjoy doing this video, and I look forward to seeing you at the next one.